Hello friends, welcome to JJ's Classroom. I am George McMahon. If you like my videos, then don't forget to subscribe my channel. In today's video, I am going to discuss with you the classification of spectroscopy on the basis of type of sample as well as the classification of EMR and some numericals. So without any delay, now go to the lecture. So the type of matter or nature of sample. On the basis of nature of sample, the spectroscopy is classified into two parts, molecular spectroscopy as well as atomic spectroscopy. If your sample it is in the molecular form, then the technique is called molecular spectroscopy. But if your technique it is in atomic form or ionic form, then it is known as the atomic spectroscopic technique. The common point between these two techniques is when the electromagnetic radiation incident on a sample, either it is in a sample form, it is in a molecular form or atomic form, they undergo absorption, emission or scattering of the electromagnetic radiation. That is a common between these two techniques. Now, which kind of information you generate when you study the molecular spectroscopy or the atomic spectroscopy? In molecular spectroscopy, the information regarding to chemical bonding in a molecule is observed, while in atomic spectroscopy, the information regarding to elemental analysis is there. That means analysis of carbon, hydrogen, oxygen, nitrogen, that is called elemental analysis. Next point, that is in molecular spectroscopy, samples are utilized directly for the analysis, but in case of atomic spectroscopy, first you must atomize the sample. That means your atom are converted into free gaseous atom. This process is known as atomization of the sample. Okay, conversion of sample into free gaseous atom called atomization of a sample. Some example of the techniques like UV visible, IR, NMR, those are the technique of molecular spectroscopy, while AAS, AES, FES, AFS, X-ray, ES, those are the atomic spectroscopy. AAS stand for atomic absorption spectroscopy, AES stand for atomic emission spectroscopy, FES is for flame emission spectroscopy, AFS stand for atomic fluorescence spectroscopy, ES stand for electron spectroscopy. Okay, those techniques you studied in MSc semester 3. Okay, while molecular spectroscopy technique you broadly studied in MSc semester 4 spectroscopy 2. Okay, NMR, that is a nuclear magnetic resonance. The basic difference here between AAS, AES and FES, that means if when EMR is incident on the sample and if you studied how much amount of the radiation is absorbed by the sample, then it is called atomic absorption spectroscopy. But if you study how much amount of the radiation emitted after absorption of the radiation, then the technique is called atomic emission as well as flame emission spectroscopy. The difference between AES and FES is radiation source. In AES, radiation source are like arc, spark, plasma, while in FES, radiation source is a flame. Okay, a well-known instrument known as a flame photometer is working on the principle of FES, that is a flame test. Okay, flame test is the principle of that flame photometer. AFS, that is atomic fluorescence spectroscopy in TYBSc, the unit is there photochemistry. In that unit you already studied the fluorescence as well as phosphorescence phenomena. Okay, that is atomic fluorescence spectroscopy. Now next, that is the EMR classification and some numericals. Okay, here I give you one table which indicate the radiation under the title of EMR, starting from radio wave, microwave, IR is subclassified into three parts: far IR, fundamental IR, near IR, visible, near UV, vacuum UV, X-ray and gamma ray. So those are EMR radiation. The wavelength of the radiation is given in the table. Okay, you must remember those values. Okay, the values are given here. As a point of numericals, how the numericals are from the table, it's like this. I give you one example of it. Okay, if for near IR, wavelength is given to you 2.5 micrometer, and you have to calculate the value of frequency and energy. Then how could you calculate the values? By using only wavelength? The answer is, you know the relationship between the frequency nu and velocity of light c and a wavelength lambda. Okay, if you put the values here and if you rearrange the equation, the velocity of light c is 3 into 10 raised to 8 meter per second. Okay, you must remember this value also. It is also 3 into 10 raised to 10 centimeter per second. The value of wavelength is given to you, that is 2.5 micrometer. Okay, if your velocity is in the meter, so you must convert the micrometer value into the meter, that is 2.5 into 10 raised to minus 6 meter. Okay, you must know the conversion factors like micrometer is a 10 raised to minus 6, nanometer is a 10 raised to minus 9, picometer is a 10 raised to minus 12, millimeter is a 10 raised to minus 3. Okay, so what will be the value of frequency now? Okay, you have two values with you, that is velocity, okay, and the value of wavelength. Just put the values here in the equation and you got the answer by simply calculating it. Okay, units are compulsory here. If you forget to write down the units, then the marks will be minimized, or we can say that वो आपके marks वहाँ पे cut हो सकता है. Now, how you can find out the value of energy? You know the relationship between the energy and frequency is equal to h nu. Here h is a Planck constant, 6.626 10 raised to minus 34 joule into second, or 6.626 into 10 raised to minus 27 erg into second. You must remember the value. So put the values here. Value of Planck constant, you already find out the value of frequency, put both the values and calculate it, you got your answer. So that's how, if you have the value of any one data, like if you have the value of wavelength, then you can find out the value of frequency and energy. If you have the value of frequency, then you can find out the value of wavelength and energy, and vice versa. If you have the value of energy, you can find out both the value of frequency and a wavelength. Okay. Here I give you the table, that is calculated values here, that is from our calculation, and the next line, that is observed value, the original values. Look at here, both values are same. So that if you calculate all those values, okay, this table, okay, here all are question marks. Now you utilize all those data of wavelength, and if you calculate them, you can remove those question mark with the suitable answer by using our calculation. Okay, I already solved that for you. If you want to cross check it, sorry, here is your table. If you want to cross check it, you can utilize any value and put them in the equation. You got all these data. Okay, some numericals for your SAP study. The value of wavelength is given to you. You can easily find out the value of frequency and energy. One more example, energy is given to you. You must find out the value of frequency and wavelength. Now you know the relation between energy and frequency. E is equal to h nu. Put the value of energy, put the value of Planck constant, rearrange the equation, you can find out the value of frequency. Then with the help of a frequency and a velocity of light, you can find out the value of wavelength. Similarly, if frequency is given to you, find out the value of wavelength by putting the values in nu is equal to c by lambda, and find out the value of energy by put the values of frequency in E is equal to h nu. So that's all about today's lecture. I hope you understand it and you like it. If you like the video, then don't forget to subscribe my channel and press the bell button also. So thanks for watching, friends. Have a good day and please be safe.